So this is Mrs. Huntley. This is Module 4, Lesson 11, Constant Rate. You should be on your student workbook, page 87. And your essential question for this lesson is how are equations, tables, and graphs related? So we're going to start off with a story problem, similar to the ones that we did in the last lesson. So Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn or a section of the lawn in 2.5 minutes. So 35 square feet in 2.5 minutes. What area in square feet can she mow in 10 minutes? So again, we're going to start setting up a proportion to see if we can solve for 10 minutes. So keep in mind we've got distance over time. Our distance here is a square footage. So we're going to have y equal our square foot and x equal our time. So we've got 35 square feet in 2.5 minutes. And we're going to set that equal to, we don't know the number of square feet, so we'll call it y, over 10 minutes. And again, cross multiply. So 2.5y is equal to 35 times 10, it's going to be 350. And then divide both sides by 2.5, and you'll have y equals 140 feet in 10 minutes. Okay. The next part asks us to write a two-variable equation that represents the area of the lawn y Pauline can mow in x minutes. So again, it's just like the lesson yesterday where we're setting up the two-variable equation with y isolated on the left-hand side. So 35 over 2.5 is equal to y over x, cross multiply. So we'll have 2.5y equals 35x. Divide both sides by 2.5 to get the y by itself. And 35 divided by 2.5 is going to be 14. So y equals 14x. What does that mean? This represents the rate at which the lawn is mowed. So I can plug in any value of time for x, and I'll know how much square footage is being mowed. So let's put this to the test here. Now, they changed the variables here. They're saying time in minutes would be t and area in square feet is y. I like to stay consistent. I'm just gonna call this an x. I think we can understand that x is going to be representative of time instead of the t. We don't have to have the first letter of the word that it's representing. So y equals 14x is our equation. So I was saying we can plug in or substitute in any value for x and figure out the square footage that's being mowed in that time. So here's an example. If I have y equals 14x and I substitute in 0 instead of x, 14 times 0 is also 0. So my y value is going to be 0 here. The next one, y equals 14 times 1. 14 times 1 is 14. So I know my y there. Next one, y is equal to 14 times 2. Hopefully you know that one off the top of your head. That one's going to be 28. Y equals 14 times 3. 3 times 14 is 42. And the last one, y equals 14 times 4. 14 times 4 is 56. So here we were plugging in all of those, or substituting in all of those different time in minutes, and we were able to figure out the square footage of lawn that was being mowed in that time frame. So we're going to graph it, and we're going to look at what the graph looks like. So at 0 minutes, we have 0 square foot. And at 1 minute, we have 14. If you look on the left, our graph is going up by 5s. So that's not a 1, that's actually 5, and then 10, 15, 20, etc. So in 1 minute, we're at 14. So that's going to be slightly below the 15 here. And at 2 minutes, we are at 28. So it's going to be a little bit more than halfway between the 25 and the 30. And at 3 minutes, we're at 42. At 4 minutes, we're at 56. So that's how I would graph that linear equation. Okay, let's move on to the next one. So let's attack some vocabulary here. We've been talking about average rate and constant rate. What is the difference? The average rate is the rate at which something is done in a specific time interval. In other words, when we said, and I'll flip back, don't worry, when we said Pauline is mowing and she mows 35 square feet in 2.5 minutes, that means somebody timed her and they were able to time her for 2.5 minutes and calculate how many square feet she did, and then they divided that to figure out the average. Now we're assuming when we're taking that average and we assume that the constant rate assumes that the average rate is true over any time interval. So when we're taking that average that we figured out that Pauline could mow in that 2.5 minutes, and we're extending it over and we're saying we're going to assume that she's not going to stop and take a break, she's not going to have to slow down around corners or anything like that, she's just going to keep mowing at that constant rate continually. And that's the difference. So basically, the constant rate assumes that the average rate won't change over an extended period of time. So let's look at another example here. If you have to pause the video to get those down, by all means, please do, but I am going to move along. So we're looking at a water flow rate. So water flows at a constant rate out of a faucet. Suppose the volume of water comes out in 3 minutes is 10.5 gallons. How many gallons of water comes out of the faucet? It says in T minutes. I'm going to change that T to an X. Let's just keep it consistent with the variables that we're using. So how many gallons of water will come out of the faucet in X minutes? So again, our volume here is going to be our Y, and time is going to be our X. Okay. Set it up the way we've set up all of the other problems. So we've got 10.5 coming out in 3 minutes. So 10.5 in 3 minutes, and we're setting up a 2-variable equation. So our Y is going to be over our X, and we are going to cross multiply. So 3Y equals 10.5X. Divide both sides by 3, and we get Y equals 3.5X. Again, this is the rate at which the water is coming out of the faucet. Okay, so Y equals 35X represents the rate at which the water is coming out of the faucet. So just like the last example, we are going to set up a table, and then we're going to graph our results. So let's recopy our equation here. Y equals 3.5x. You can go ahead and pause the video here and then just rewrite the equation, substituting in whatever value is over here. And then calculating it out, 3.5 times 0 would also be 0. I'm going to change this one to a Y, change this to an X. Okay, go ahead and pause it and finish filling out the table here. Okay, go ahead and check your table. Make sure your values match mine. And if your values match mine, you can pause the video again and go ahead and work on graphing your results. Again, this is your X, and this is your Y. So like I'll do the first one with you. In 0 minutes, we've got 0 gallons. So here's where the first one's going to be. Then in 1 minute, we've got 3.5 gallons. These are going up by ones here, so 3.5 is going to be halfway between the 3 and the 4. If you cannot read the numbers, count the lines. So we've got 1, 2, 3. Halfway between 3 and 4 would be right about here. So I've done the first two for you. Go ahead and pause the video and see if you can do the remainders. Okay, check your graph. Make sure your graph looks like mine. If you have any questions, note them on the page so that you can ask them when you get to class. And let's turn the page. This next one is an on your own problem. So Juan types at a constant rate. He can type a full page of text in 3.5 minutes, and we want to know how many pages, we're going to call it y, Juan can type after x minutes. So again, I'm changing the variables to the y and the x because we know how to deal with y's and x's. We've been dealing with it all along. So instead of distance over time here, we're going to have pages over time. So pages over time, and that is our y over our x. What I would like you to do is go ahead and figure out the linear equation. Pause the video, figure out the linear equation, unpause the video, check your work, and then we'll move on to the rest of it. So go ahead and pause right here. Okay, so hopefully you set it up as 1 page over 3.5 minutes is equal to y over x. Then you're going to use your cross products property, and you'll get 3.5y equals 1x. Divide both sides by 3.5, and you'll get y equals 1 over 3.5 times x. If you do this calculation in your calculator, you're going to get 1 divided by 3.5. You're going to get a really long decimal, 0.2857142286, etc. I'm going to encourage you to not do that because it's a long decimal. I would rather that you just use the fraction here so that you're getting more precise numbers. So if we recopy our linear equation here, y equals 1 over 3.5x. Going to plug in our different values for x, calculate what y would be, and I'm going to ask you to pause the video, complete the table, and then unpause the video to check your answers. Okay, so hopefully your y values turned out to be the same as my y values. I had to kind of stagger my work in the center here where the linear equations were supposed to be listed out because the stylus is quite thick, and as a result I don't get very fine points as far as my work goes. So it's a little bit sloppy, but you can see that I plugged in the 0, the 5, the 10, the 15, the 20, and I used my calculator to figure out the answers. Now, how I did this in my calculator, there's a number of different ways. You can put in the fraction 1 over 3.5 and multiply it by whatever number it is. What I did just for ease, 1 over 3.5 times a number, well, 0 was easy. Let's do 10. I did 1 times 10 divided by 3.5, and that's going to give me the 2.9. So however you worked it out in your calculator, that'll work. The next thing we're going to do is graph this data, but what I want to alert you to is that the graph got mixed up in the copying process somehow. So these numbers got skewed downward. That should actually be 0. So this first one is 1, 2, 3, 4, 5, 6, 7, 8, 9, and the very top is 10. And then they're skewed a little bit at the bottom too. 1 looks fine, but 2 is a little bit off, then 3 is more off, 4 is really off, etc. So each line represents 1 unit here. So you're probably going to want to renumber before you start graphing just to make sure that you don't have something that's messed up. Okay, so fix your graph first. Go ahead and pause the video and see if you can get this graph to be right. and we'll see you in a minute. Okay, take a look at your graph, see if it matches my graph. Um, we are counting by fives in the x's, so notice that they're not every line, that they're, here's the 0, 1, here's the 5, 1, and at 5 we were at 1.4, so it's going to be between the 1 and the 2 as you're going up, and hopefully that worked out correctly for you. If it didn't, please correct your work right now. Now part D says, about how long would it take Juan to type a 5-page paper? So let's come back up top here and let's look at the pages that are on the right. So if you look, it takes Juan 15 minutes to type 4.3 pages, and it takes him 20 minutes to type 5.7 pages. So at 5 pages, we're going to be between these two. So we need to look at the time that we're talking about on the other side. So between 4.3 and 5.7, somewhere between 15 and 20 minutes is how long it's going to take Juan to type 5 pages. Now, we have this magical word here that says about, so they're not asking us to actually substitute in 5 pages for our y value and solve for the time. They're saying estimate it using the tools that you have. So if I am looking at the table, I can see that it takes Juan 15 minutes to type 4.3 pages, so it will be greater than 15 minutes, and it takes Juan 5.7, or I'm sorry, he types 5.7 pages in 20 minutes, so it's going to be less than 20 minutes. So somewhere between 15 and 20. Now the other thing that I can look at when I'm trying to figure this out is the graph. If I look at the pages typed here at 5, and I follow that line across where I think the data would cross this 5 line here, so if the trend continues, I'm guessing that right about here, somewhere between 16 and 17, is where that, and what I'm talking about is I follow it down then. So somewhere right around there is where, if the trend continues, that's where we're going to be, between 16, maybe 17 minutes for Juan to type those 5 pages. So again, I can use the tools that I have to estimate. So that's how I would do this. Okay, we're starting to get a little bit long here, so I am going to end this part of the lesson right here. We'll pick up the rest of the lesson on 11B, but for now, that's it, and I don't have any additional work for you to do before you get to class, so I will see you in class. Make sure you bring your questions. Have a nice day.